let's try to solve this problem here. A car is traveling at 20 meters per second, is at a distance of 50 meters from a stationary lorry when the brakes of the car are applied. Okay, so then the car crashed into the lorry 4 seconds later. Okay, we say we stop here. We try to visualize the situation first before we move forward to look at the sub-question. Okay, so it mentions that you have a car and it's traveling at 20 meters per second. Let's write that down. Let's draw that down. Okay, so let's say I use a square here, then I label it as C to show that it's a car. And this car is traveling at 20 meters per second. Okay, then this car is now at a distance of 50 meters away from a stationary lorry. So if I have another lorry here, and this lorry is stationary, 0 meters per second. Okay, now they say that you are applying a brake to the car. Okay, so you are pressing the brake for the car, so I believe there's a deceleration that happens. Okay, so if you don't want to get confused where's the direction of acceleration and stuff, right, you can just write it's decelerating. Okay, the car crashed into the lorry 4 seconds later. Okay, when they say the car crashed into the lorry 4 seconds later, means by the car will travel this distance here, which is 50 meters, and it will crash it within 4 seconds. Okay, it will take 4 seconds for this car to move from its initial position until it touched the lorry. Okay, and the distance is 50 meters. So I believe that's all the information that you have for now. Yes. Okay. So they asked for what? A, the speed of the car just before colliding with the lorry. So they asked for the speed of the car when the car is at somewhere around here. Or you can think of it as what is the speed of the car after it has traveled for this 50 meters over here. Okay, so let's proceed with step 2. So our for question A, our step 2 will be initial, final. Okay, so our initial is over here. This is for question A. Initial for question A, you're over here. Final for question A, you are somewhere around here, right? Because when just before colliding, it's like about the time you collide, before you really touch the lorry, what's the final velocity before you touch the lorry? So somewhere around here. And this is for the car. They're asking for the car. They're not talking about the lorry at all. So everything here is related to the car. Okay. So we have determined the initial and final position. Next step, we do our SUVAT. So SUVAT. So SUVAT. Write down everything. Then write down everything that we know. So we know that the distance traveled here will be, the displacement will be 50 meters. From the initial position to the final position, the displacement is 50 meters. So you can write 50 meters over here. Initial velocity, well, it's being stated over here. It was previously at 20 meters per second. So 20 meters per second. The final, well, they asked for it. They are not asking for it. The speed just before colliding. So that's what they're asking for. So keep it blank. Then the acceleration, what should you write? Well, you know the person is stepping on the brake, so you know it's decelerating, but you don't know exactly how much is it. So you leave it a blank as well. Then how much time? Well, it takes 4 seconds for it to travel from its initial position until it collides with the lorry. So the time duration should be 4 seconds. Okay, so that's all that we know about the situation. We have filled in all our SUVAT. So now we move on to the next step, which will be to determine the suitable equation. So what equation will be suitable? Let's check. What do you want? We want the speed just before colliding. So that means we want the final velocity. Okay, then what do we have? We have our displacement, we have our initial velocity, and we have time. So you want the equation that has S, U, V, and T inside it. We don't want an equation that has A inside it. So which equation is suitable? We don't want A inside, so this will be the equation. It has S, U, V, and T. So S equals to half U plus V, T. So that's the equation that we are going to use here. S equals to half U plus V, T. So let's substitute. This one will be 50 half 20 plus V is something we don't know, T. Okay, T is 4.0. Now after we substitute in everything, we should get our V to be 5.0 meter per second. And this is our substitution and answer. Okay, so this is how we managed to solve our question. In an exam, what they want to see is only this part. Okay, they want to see this part of your working in exam, but this part of the working is only possible if you complete the diagram first, determine the initial and final first, do your SUVAT first, fill in all the blanks first, and only you should arrive at this step. Well, the marks is only allocated for this part, but it's important that you do all the previous step because it's a systematic way to solve the problem. If you jump step, then later you will encounter situation where you don't know which one should be S, which one should be the initial. Okay, so do it systematically, please. Okay, let's try and proceed with question B over here, and I'll show you how I will write it in an exam setting. Okay, in an exam setting, you don't really need to write step 2, step 3, step 4, step 5. I'll show you how I write during exam. Okay, so if it's for question B asks for the car's deceleration. Well, the deceleration it's a process, it's a constant process that happens throughout this journey over here. During this whole journey, the brake is being stepped on, right? So deceleration is happening throughout this journey here until it collides with the lorry. So you should expect the journey here, which is sandwiched by this point and this point here, to be our initial and final position. Okay, so let me write it down. So this will also be our initial for B, and this will also be our final for B. And it's asking about the car as well. This is also asking about the car. Okay, so this part you can still write it in the exam like this. But next we move on to step 3. In step 3 you write SUVAT. So yes, you write SUVAT. You don't need to write down this is step 3 or something. Just write something like this will be fine enough. Okay, then you fill in the blanks, and because they share the same initial and the same final position, you can get the same SUVAT from before. So you have 50, 20 meter per second, and 4.0 second. And now you obtain something new, which is the final velocity, and you can put that in. Okay, then after that you find the suitable equation. Suitable equation, what do you need to find? You want to find the acceleration. Then what you have your S, U, V, and T. Well, so technically you can use any of the equations as long as there's an acceleration inside, because that's what we want to find. But which equation will be the better equation to use? The one without the answer from the previous sub-question. Okay, so we choose to not have this final velocity here, and if we deselect this final velocity, then we left with S, U, A, and T. So what equation is suitable for this situation? S, U, A, and T. S, U, A, and T. So this will be the equation that we use. Okay, so now we use the equation S equals to UT plus half AT squared. And now we substitute in our value. 50 equals to 20 times 4.0 plus half acceleration, don't know, right? A t square 4.0 square. And if you calculate everything here, you get our A to be equals to negative 3.75 meter per second square. Okay, you might think that's the end, but no, they're asking for deceleration. They are not asking for acceleration. So if they say deceleration, then you have to, deceleration means slowing down already. So the negative sign and deceleration, they are redundant. So you have to remove it. So you can say deceleration is equals to 3.75 meter per second square. Okay, so this is how I will write it in an exam setting. I won't write the step 2, 3, 4, 5, but I will write down the complete SUVAT, an equation that I choose, and substitution, and the answer with unit. That's the least that I can do. That of course it should come with a diagram in the first place. Because without the diagram, you can't even start with the SUVAT, you can't even get the equation, you can't even do substitution. Okay, so I'll do this, and this to complete my working in an exam or in any tutorial setting. Okay, so that's for this example.